Hello everybody, welcome back to today's video. This is part 6 of the Solving Linear Equations series, and today we're going to be talking about how to rewrite literal equations. So what exactly are literal equations? They are equations with two or more variables. So instead of solving for one variable with a number on the right side of the equal sign, we're now going to be solving for a variable where the other side will also contain variables. And right now it might sound confusing, but it's fairly the same thing that we've been doing in the other parts. So let's go ahead and look at example 1. The goal for this example is that we're solving for y. We want to isolate the variable y, which means that we want y to be on one side of the equal sign independently. So first we locate the y in the equation and we see that it's associated with the 3. So our goal is to make 3y on the left side. So we can do that by subtracting 4x on both sides of the equal sign. Once we do that, then we get 4x minus 4x is 0. 9 minus 4x is not 5x, it's actually 9 minus 4x. That's a little error I made. On the left side, we have 3y. We divide both sides by 3 to make y independent. 3 divided by 3 is 1, so y is equal to 9 minus 4x divided by 3, as I have written and corrected in the black font. And you might be like, wait, shouldn't we have an integer or some type of a number answer there? And what do we do with the x? And the thing is, we do nothing with the x. We leave it as it is because what we're trying to do is just isolate y. And there will be other variables on the right side of the equal sign, and that's okay to just leave them because there's nothing we need to do with them. All right, let's do example 2. Here, again, we are isolating y. We're trying to solve for y. So that's our goal. So what we will do is we'll see that, okay, there's y is only once in our equation. So let's add x to both sides of the equal sign so we can go forward with making y independent. So we have 3y on the left and 9 plus x on the right. The negative x plus x will just cancel out to be 0. Now we'll divide both sides by 3 to make y independent, and then we get y is equal to 9 plus x divided by 3. And that will be our final answer. And of course, you can plug this back into the original equation just to make sure that this answer that we got satisfies the equation. So we can go ahead and box this, and this is our answer. So it's as simple as that. We're just trying to make the variable independent. All right, so let's go ahead and do example 3. Here we're trying to make x independent. So we must locate it in the equation. We see that it's in there twice. So what we can do is that we can actually take the x variable out. So what I want to say and make a side note of is right now we have y isolated. We say y is equal to this, but we're trying to say that x is equal to this. So our formatting of the answer is different. So make sure you know what variable you're isolating. All right, so we have y is equal to 3x plus 5xz. We can take the x out. So we have 3 plus 5z. And what I did here is reverse distribution. You know, if I factor x back in, I can have 3x plus 5xz. So we know that we did it correctly. If this distribution doesn't make sense, I've done a lot of distribution in my past videos, so go ahead and check that out, or you can check out another video about distribution. All right, so now what I'm going to do is I'm trying to make x independent, so I can divide both sides of the equal sign by the expression 3 plus 5x. By doing that, I have x independent, and on my right side, I have y divided by 3 plus 5x. And actually, that x is supposed to be a z, so my bad on that. So we can go ahead and fix that little mistake. So now we actually have x independent. So x, I'll just rewrite it, x is equal to y over 3 plus 5z. So we can box that and we're done, right? So we made x independent. we isolated x. Okay, now we have a question like this. This has a lot of variables in it. We got surface, that's what S is, length, width, height. So we all have those variables. In this question, what we're trying to do is we're trying to solve for the variable L, which is length. So first we locate it. Where is it in our equation? We find it, and then we try to isolate it. So we see that we have plus 2WH. That doesn't have an L in it. Let's go ahead and just take that away and move that to the left side. So we'll have S minus 2WH is equal to 2LW plus 2LH. All right, so now we have L on the right side. Let's just take it out. So it's a form of reverse distribution. So we can say L times 2W plus 2H. If we factor that back in, that would be the same as distributing. Now we're going to divide both sides by 2W plus 2H, that expression. So then we have L independent, right? So there's a lot of moving parts, but the process is pretty much the same. The goal is the same. So now that we have L, we can say that L is equal to S minus 2WH divided by 2W plus 2H. So that would be our final answer. And you might be like, okay, so what is the need for solving for a variable? And in this equation that we have, we are able to, let's say we had all the other variables. We know the height, we know the width, we know the surface area, but I don't know the length. By isolating L, I can figure out the length. So that concludes today's video. Hopefully all of these examples that I provided made sense, and please subscribe to our channel.